we're going to continue our discussion of derivatives involving trig functions by adding on 4 more trig functions. So at the top you can see I've brought over the derivative of sine and derivative of cosine. Just to remind you, we talked about that in a previous video. And then below it you can see we have 4 more. So these are the 6 traditional trig functions, or all 6 trig functions that we usually talk about. We're going to spend a lot of time on sine, cosine, tangent. Secant will come up frequently. Cotangent and cosecant, you'll see them occasionally, but you're not going to see them quite as much. You still need to know them. You still need to memorize these formulas, but the most common ones will be sine, cosine, tangent, and secant. Now, there are some commonalities here in this box. So the derivative of tangent is secant squared, and we can prove that using the limit definition. It's in the textbook. You feel free to read it. The derivative of cotangent, I want you to look at the similarity here. So these two are co-functions, tangent and cotangent. The derivative of the co-function is cosecant squared with a minus sign. The derivative of tangent is just secant squared. There's a relationship there. If you put a co-function, it's the same derivative but with a co. So instead of secant squared, we have cosecant squared and a negative. Similarly for secant, we take the derivative of secant, you get secant tangent. When you do cosecant, you get cosecant cotangent. You see the similarities? Just put co on everything. But whenever you do a co-derivative, you need a negative. Same thing with cosine, you need a negative. All right, so watch out for that trick. That'll help you a little bit to memorize it. I've got some examples here. So these are going to use the ones above, but also some other rules that we've already talked about. So I want you to look at this problem, and I want you to look at the big picture here. What's going on that's holding the problem together? You've got to figure out what the main operation is to determine your main derivative rule. So I see a cosine, but cosine is not what's pulling everything together. There's an x squared hanging out front. What is pulling the x squared and the cosine together? What's the operation between these two functions? You should be saying a product. The product is what's pulling it together. So that is the first step when we take the derivative here, is to use the product rule. You have to look at the big picture and see what operation is pulling it all together to figure out where to start taking your derivative. So product rule, hopefully you remember that rule. It's u prime times v plus u times v prime. So we had to write down u, write down v, and then take the derivatives. So I'm going to let u equal, remember it doesn't matter in product rule who is who, just make sure everybody goes somewhere. So u is going to be my x squared, v is going to be my cosine of x. The derivative of u, all right, derivative of x squared, hopefully you've got your power rule down, 2x. The derivative of v, so this is our new one. Remember, whenever you have a co, you're going to need a negative in your answer. The derivative of cosine, if I go back up to the top, you should see it's negative sine. So these are all the pieces that we need in order to complete our product rule. So the product rule says u prime times v, so multiply these two, plus u times v prime, multiply these two. So let's write it out. So y prime, or you could write dy dx. The derivative of y is equal to, okay, according to product rule, I need my u prime times my v, that's cosine of x, plus u, that's x squared, times my v prime. Make sure you put parentheses because this needs to be a multiplication here. If you don't put parentheses, it's going to look like a minus sign, and I have students write it like a minus sign, and that's not what it is. So because of this multiplication, I know that I need to multiply the negative sign times the positive x squared. Simplify, so you have 2x cosine of x minus x squared sine of x. If you want to factor out an x, you can, but this would be good for me. I'd be happy with this answer. So notice trig was involved, but it was a very small part of the problem. Okay, it can also be a bigger part of the problem. It depends on where it's at. So as we go through more and more rules, you'll see how trig can play a bigger role in each problem. All right, so here's another one. What is pulling everything together? Well, first of all, I see the plus sign is what's pulling these two terms together. But plus sign, that just means we do each term separately. Well, the last term, that's the easiest one. So let's look at that first. What's going to be the derivative of 5? Well, that's a constant. What's the derivative of a constant? That's just going to go to 0. The derivative of a number by itself is 0. So that's gone. You don't need to worry about that. This other piece here, what is holding the square root and the secant together? What's in between the two? A product. So we need to do the product rule again. Product rule is very common, so get used to it, get comfortable with it. He's going to come around. Well, I don't need that yet. First, we got to find all the pieces. So remember, product rule is u prime v plus u v prime. I don't care if you have it right above, write it. That's how you're going to memorize the rule. Write it every single time. So that's going to be our f prime of x. Let's write down u, v, and their derivatives. So I'm going to let you have a choice here, be the square root of x. You could have let it be secant. It doesn't matter for product rule. I'm going to let v equal secant of x. Make sure everybody's somewhere in there, except for the 5. 5 you already took care of. How do we take the derivative of a root? That's kind of tricky, isn't it? Remember, algebra is your friend in calculus. Use algebra to rewrite this. If you rewrite it, how could you rewrite that? Instead of writing a root notation, write it as a power. Okay, there you go. So the derivative of this, we can use the power rule now. Power comes down, x to 1 power less. So it's negative 1/2. 1/2 minus 1 is negative 1/2. The derivative of v, all right, what was the derivative of secant? If we go back up, we can double check our rules. Make sure you memorize this. The derivative of secant is secant tangent. So we're going to write that here, secant tangent. This is everything you need to fill into your product rule. So our product rule, y, or f prime, let's call it f prime of x is equal to, all right, so I'm just following the rule over here in red, u prime times v plus the u times v prime. So 1/2 x to the negative 1/2 times secant of x, that's our u prime times v, plus the u, you can use the x to the 1/2 or the square root notation. Either one of those would be fine. Times v prime, that's secant tangent. You might want to write it with positive exponents or with square roots, but really this is okay. So let me go ahead and write it one other way. 1/2, bring your x down. This negative exponent can come down. Write it as a root or as a power, either way. Secant x plus, we can write this as a root. Make sure secant and tangent aren't inside that root though. So either one of those I would consider to be complete. If you were doing a multiple choice test, you'd have to make it match, but otherwise that should be good. All right, so those are 2 examples. Let's see if I can do another one down here. Ooh, this one's got cosecant, but don't get caught up in the trig. Look at the big picture. Big picture, what's pulling all of this together? Well, first of all, we have a minus, which means we do each one separately. Well, cosecant is just a rule by itself, so we can go look that one up. Over here, we have 6/e to the x. Now, further down the road with our derivative rules, we're going to have what's called a chain rule. Chain rule would actually be the way to do this, but we don't have that yet. So what would we have to use for here? I can't bring e to the x upstairs as if it were x to a power because that would make me have a negative x. My e to the x rule only works if it says e to the x. So I have to leave e to the x where it is. So that means I have to work with this quotient. I have no option. All right, so we're going to need the quotient rule for that piece and the derivative of cosecant for this other piece. Let's go ahead and write that down so we have it. So remember, go back up. When you do a cofunction, you need a negative. Cosecant is cosecant cotangent. So negative cosecant of x, cotangent of x. That's going to be the derivative of that piece. And then we need the quotient rule. So let's write that down. What is the derivative of a quotient? The derivative of the top times the bottom minus the opposite. Top times the derivative of the bottom, all of it over the bottom squared. So remember, this is just for this piece. So my u is the top, my v is the bottom. Write them out. So let's see, right, u equals 6, v equals e to the x. To do the quotient rule, you need u prime. Wait, what's the derivative of a constant? 0. What's the derivative of v, or e to the x? Well, that's awesome. That's just itself, e to the x. So the quotient rule says we're going to do u prime times v minus u times v prime. So we're going to write it all out here. The derivative of y prime. We already found the derivative of cosecant. That's negative cosecant x, cotangent x, minus, because your fraction has a minus in front of it, the quotient rule. U prime times v. So that's 0 times e to the x. What's that really going to be? 0 times anything is 0. So that's really just going to be 0. You can skip it if you want. Just cross it out. It's gone. But I'm going to go ahead and write it to show my work. U times v prime, that's 6 times e to the x. And all of this is over v e to the x squared. All right, let's clean it up just a tad. First term, we can't really do anything to. The second term, this is 0, so this is gone. And then we have a negative and a negative, which make a positive. And we have 6 e to the x over e to the x squared. Wait a second, I have e to the x on top and bottom. Well, technically these two multiply, so you could write 2x, but because I have e to the x on top and bottom, it's actually better for me to cancel. Cancel 1 e to the x on top and 1 of the e to the x on the bottom. So what do you end up with? Negative cosecant of x, cotangent of x, plus 6 over e to the x. This is how I would stop. I would stop right here and write my answer. Okay? Got a couple more for you. Just keep getting more and more interesting. It's exciting, isn't it? All right. So here we have, oh boy, we have 3 things, all multiplying. Okay, wait a second. These are multiplying, but what is this? This is just a number. He's a constant multiple, so what does he do? He just hangs out, chills out while we take the derivative of the rest. So let's focus on the rest of this. What is making secant tangent together? What's putting them together? What's in between? Multiplication. This is a product, which means you need the product rule. So product rule says u prime times v plus u v prime. Why don't you take a minute, pause the video, and try this one on your own. See if you can get it. Come back and watch the video and see if you got it right. Alright, so if you pause your video, let's write down and see if you guys got everything worked out here. So I'm going to call u the secant of x, and v, I'm going to let that be the tangent of x. So u prime, remember what the derivative of secant is? Secant x, tangent x. The derivative of tangent, we haven't looked that one up. Go check in your notes. It's secant squared of x. So here's all your pieces. And there's your rule. You're just going to plug them in. All right, I think I'm going to need to do it over here. So I have plenty of room to simplify. G prime of x, the derivative. Don't forget that 7. That 7 out front has to multiply by everything. So I'm going to do big, giant parentheses here. All right, u prime times v plus u times v prime. Multiply them together. So secant tangent times another tangent plus secant times secant squared. All right, 7 comes down. We can simplify. These two have tangent multiplying, so secant times tangent squared. Remember, when you do a square on a trig function, you have 2 ways to do it. You can put it on the word, or you can write parentheses around it and square the whole thing. That's something that a lot of students forget, so just a reminder. Plus, secant times secant squared, well, that would be another secant, so secant cubed. Or, maybe it's a multiple choice and you've got to match. You could factor out a secant because both terms have secant and write tangent squared plus secant squared. Right? Now, some of you might be wondering, is this an identity? Remember, the identity that's similar to this is tangent squared plus 1 equals secant squared. So if you bring tangent around, it'd be negative. If you brought secant squared around, it'd be negative. So it's not a sum of the two. It's a difference of the two is the identity. So I would leave your answer in either one of these formats. You could also distribute the 7 in if you wanted to, but that would be how we would leave that one. Okay. All right. Got 2 left. Let's see if we can get these done. So what is the overall rule that we need to apply? Well, some of you might actually question if we could do algebra. Algebra is always a good thing to ask. Could we separate this out and do cotangent over 1 plus cotangent over cotangent? Remember, if the addition's in the bottom, you cannot break it up. If the addition's in the top, that's when you can break it up. So in this case, can't break it up. Can't do an algebra trick. So I think we're stuck with a quotient rule. So let's give that a shot. Quotient rule, how does that work? Well, we're going to call the top U, and we're going to call the bottom V. The quotient rule is going to be the derivative of the top times the bottom minus the top times the derivative of the bottom all over the bottom squared. So let's write down all of our pieces. So if U is cotangent of x and V is 1 plus cotangent of x, the derivative of cotangent. Well, I did the derivative tangent a minute ago. That was secant squared. So cotangent would be cosecant squared with a negative sign. V prime, well, derivative of 1, that's a constant, so that's gone. And cotangent, that's the same thing, so that's negative cosecant squared of x. So according to the quotient rule, we're going to do u prime times v minus v prime times u. Let's plug that in. So y prime, let me leave some room in case I need to simplify. So y prime is equal to, all right, u prime is negative cosecant squared of x times the original v. Make sure you put it in parentheses. Minus the original u cotangent times v, the derivative. Careful, it's got negative, so make sure you put parentheses. Okay, draw a line to separate these because I got really close. There we go. All right, so let's clean it up. Let's see, we could distribute. We could simplify these signs at the end. These are 2 negatives, make a positive. Let's see, that's going to be cosecant cotangent, and here we have cosecant cotangent. So let's go ahead and distribute, see if we can simplify. So if I distribute negative cosecant squared to the parentheses, and then the last two, well, we already did the sign, so that's plus cotangent cosecant squared. We actually have like terms right here. One's negative and one's positive, so they cancel. And we end up with just negative cosecant squared of x as the derivative. Oh, I forgot my denominator. So no, that's not just the derivative. All right. All over the bottom squared. 1 plus cotangent of x all squared. 1 plus cotangent of x all squared. So don't forget the bottom squared, like I did. It's like, I know there's something missing. There we go. And that would be your derivative. If you wanted to try and do some identities, you might be able to, but this would be something that I would type into MyLab. Okay? One more. So here, we have a couple options. What is pulling everything together? Well, right now, everything pulling together is this multiplication here. So if we did it the way it's written, we would need product rule. However, I look at this and I see 2 parentheses that have everything the same except for the signs, which means these 2 parentheses are conjugates. Well, conjugates are special when it comes to algebra. What happens when you multiply conjugates together? The middle terms cancel. So if we were to multiply, oh, I'm doing algebra, so no derivative. If we were to multiply these together, what's going to happen? Out of curiosity, let's try it. Secant times secant, that's secant squared of x, minus tangent times tangent, that's tangent squared of x. Wait a second. Didn't we just talk about this? We just said, that's right there, tangent squared plus 1 equals secant squared. If I bring tangent around, then I have secant squared minus tangent squared. You hopefully have caught on that this is going to be one that you're going to need frequently. This is one of the Pythagorean identities for trig. So if I were you, I'd memorize this. Secant squared minus tangent squared is 1. So I'm not doing calculus here. I'm still doing algebra and trig. This y, the original function, is actually equal to 1. Now let's take the derivative. The derivative of a constant is 0. You could have ended up doing product rule and a whole bunch of crazy mess with that. Or if you do the algebra first, algebra is your friend, then you could do the trig identity and you just have a constant to take the derivative of. So that was a cool problem. It's a warning to watch out for opportunities to use algebra to simplify. All right, study hard. I'll see you in the next video.